The Amazon basin not only contains the world's largest remaining tropical rainforest, it also harbors at least 10% of the known biodiversity, including endemic and threatened species of plants and animals, and its river contributes 15 to 16% of all river discharge into the oceans. With its hundreds of tributaries and streams, the more than 6,600 kilometers long Amazon River is home to the most freshwater fish species in the world. If you want to be notified of new videos, subscribe to AWZ and click the notification icon. The Amazon biome is defined as the region that is primarily covered in dense, moist tropical forest, with only minor amounts of other vegetation types, such as savannas, grasslands, swamps, bamboo forests, and floodplain forests. 8 nations, Brazil, Bolivia, Peru, Ecuador, Colombia, Venezuela, Guyana, and Suriname, as well as the French Overseas Territory, share the 6.7 million square kilometers biome. The entire watersheds extend beyond the biome and occasionally incorporate nearby biomes. The staggering variety of mammals, birds, amphibians, and reptiles that can be found throughout the biome is equally impressive. More than 30 million people live in the Amazon, a sizable area divided into 9 distinct national political systems. 350 distinct ethnic groups, more than 60 of which continue to be mainly isolated, make up the 9%, 2.7 million, of the Amazon's population, according to the coordinator of indigenous organizations of the Amazon Basin. The Amazon biome is unexpectedly fragile and close to each of us, despite its size and apparent distance. The seemingly limitless Amazon has lost at least 17% of its forest cover over the past 50 years, its connectivity has deteriorated, and many indigenous species have seen waves of resource extraction. The Amazon is undergoing an economic change based on the conversion and destruction of its natural ecosystem. However, as those forces gain power, we are also discovering that the Amazon serves a crucial role in preserving regional and global climate function, a contribution on which everyone, rich or poor, depends. Through hydrological cycles that are dependent on the forests, the Amazon's canopy cover closely links to regional climatic patterns and contributes to the regulation of temperature and humidity. Given the vast amount of carbon stored in the Amazonian trees, improper management has the potential to significantly impact the global climate. The Amazon is home to 90 to 140 billion metric tons of carbon, the discharge of even a small percentage of which would greatly hasten the process of global warming. Without accounting for emissions from forest fires, land conversion and deforestation in the Amazon currently contribute significantly to the regulation of the planet's climate, releasing up to 0.5 billion metric tons of carbon annually. Does this mean that the Amazon River basin is just a vast, uniform area of rainforest divided by a large river? Such a perception only scratches the surface of the environment's true complexity and dynamic nature. The basin actually includes a range of ecosystems and landscapes. The Amazon River once flowed from east to west, emptying into the Pacific Ocean millions of years ago. The Amazon River was obstructed when the Andes Mountains started to form along the eastern edge of the South American continent about 20 million years ago. As a result, freshwater lakes were formed, and the river's flow gradually changed to follow its present eastern course. The river flowed close to Belém, Brazil, and eventually reached the Atlantic Ocean about 10 million years ago. Between 1,500 millimeters and 3,000 millimeters of torrential rainfall fall on the Amazon rainforest annually. About half of the rainfall is attributed to eastern trade winds coming from the Atlantic Ocean, with the remaining half occurring in the Amazon River basin due to evapotranspiration, which is the loss of water from the soil through evaporation and transpiration from plants. The climate in the region and far beyond will be dramatically altered if evapotranspiration and its function in preserving ecological balance are disrupted. Rainfall in the Amazon River basin follows a seasonal pattern, and there are significant regional variations in precipitation, even near the basin's center. Iquitos, a city in Peru near the Amazon River, gets 2,623 millimeters of rain on average yearly, while Manaus, in Brazil, gets 1,771 millimeters and has a protracted dry season. Our understanding of the major ecological services that rainforests provide to the local and global community continuously advances along with our knowledge of the Amazon. Others view it as a repository of biodiversity, useful chemical compounds, or even carbon stocks for the world's rising carbon dioxide emissions. While many associate a patch of rainforest with quick rewards, some simply to put food on the table, others see it as a repository of biodiversity. But as forests burn and the effects of climate change deepen, the impact of deforestation in the Amazon continues to slowly undermine the delicate biological systems that have evolved over millions of years. Ironically, scientific research from the past 20 years has illuminated the vital ties that connect the health of rainforests to the rest of the world, even as rainforests continue to disappear. Trees contain undiscovered qualities that are essential for lowering pollution levels. Consider the gas carbon dioxide, which is released from both natural and human sources. Burning fossil fuels like coal, oil, and natural gas during the past 150 years has sent enormous volumes of CO2 into the atmosphere, which is a major contributor to the world's changing climate. Therefore, the greenhouse effect would probably be even stronger without tropical rainforests, and climate change might get even worse in the future. Forests have the ability to replenish the air that they take from it. When forests fire, carbon from the trees is released as CO2, which pollutes the atmosphere and is already present in overwhelming amounts. There are now fields for cattle ranching where there were once jungle and savanna. Termites and cattle are abundant in pastures, and their metabolic processes also produce CO2 into the atmosphere, though their role in air pollution is hotly contested. The loss of trees prevents CO2 from being converted to life through photosynthesis, and the crops that take their place only absorb a small portion of CO2 in comparison to rainforests. Massive deforestation in South America and elsewhere has greatly raised the amount of CO2 in the atmosphere in addition to industrial pollution. Tropical woodlands and forests are assumed to play a significant role in regulating local and regional temperatures because they exchange enormous amounts of water and energy with the atmosphere. The amount of water that plants release into the sky through evapotranspiration and into the ocean through rivers affects both the global climate and the movement of ocean currents. As a result, the process also maintains the local climate upon which it depends, acting as a feedback mechanism. Humans have utilized the region's insects, plants, and other species for millennia for a number of purposes, including agriculture, clothing, and, of course, the treatment of diseases. The Yanomamo and other mixed ancestry indigenous cultures have mastered the usage of chemical compounds found in plants and animals. The custom of using these herbs is often passed down by a medicine man to an apprentice. This practice has been going on for centuries and is a vital part of the identity of the people. The preservation of this knowledge for the benefit of future generations is under danger as rainforests are disappearing quickly. Less than 1% of flowering plant species, according to scientists, have had extensive research on them for potential medical uses. The abundance of fauna found in the Amazon rainforest biome is steadily declining, as are the uses that can be found for yet to be discovered plants and animals. If you enjoyed this video and would like to see more like it, subscribe to AWZ.